All right, so it says x squared is my parabola. That was this thing. Y equals 3 was this line going across at 3. And we've got diagonals of squares. So we're drawing this diagonal of the square, and then you would have the square part from there. Okay? So I would keep drawing them. They're perpendicular to the y-axis. So I would keep drawing them like this as I went, and you'd have more and more and more, but your lines would go perpendicular. You'd go across the y-axis. Okay, we're finding the volume, so we want to integrate it. When do we start making these diagonals to when do we stop making them?
From
0 to 3. We're stacking them up. Okay, you would keep having more and more going this way because they're perpendicular to the y-axis. So we're going a vertical stack. So we're from 0 to 3. 0 and 3 are what kind of numbers here? Are they x's or y values? They're y's, so it's a dy problem. Okay, so that's important. That means that these equations need to have y in them. They need to be x equals some y equation. So let's go ahead and change this one right now while we can. Y equals x squared. So if I got x by itself, it'd be x equals square root of y, and technically it'd be plus or minus. Okay, just good to get that out of the way now. That way we don't mess it up later. Because remember, if it is a dy problem, the equation that we fill in there in a second needs to have y's in them. Okay, so we need to know the area of our shape. Okay, so we want to know the area of a square given diagonals. Okay, if you remember from our notes, we technically called this a rhombus. Okay, it's a rhombus. The equation of a rhombus is 1/2 the diagonal 1 times diagonal 2. Well, if you have a square, what's going to be true about the first diagonal and the second diagonal? They're the same. So you don't need to remember this, but the equation that we're looking for is 1/2 diagonal squared, because those numbers are the same. Okay, so that's the formula we're trying to figure out, 1/2 diagonal squared. So what do we need to know about this formula in order to do it? I need to know something for what? The diagonal. I need to know what the diagonal is equal to. Okay, so diagonal is going to be equal to, when did I start making my diagonal line and when did I stop making it? Yes, and again, though, we want to know equation. And what equation did I start making it? Because it changes as I go. The width changes. From here to there, the width is changing. So I can't use numbers. I need to use equations. What's the equation? What graph? Remember, it's what graph am I touching? What graph is it over here? Square root of y. Because we want to do it in terms of y. Square root of y. That's what this curve right there is. That is square root of y. From there to where? Negative square root of y. So it's going to be that minus negative square root of y. Minus a negative becomes plus. So I can say that my diagonal is equal to 1 square root of y plus another square root of y to get me, yep, I don't know why I wrote dy there. Diagonal is equal to 2 square root of y. Okay, I did not do a good place of space management here, but that's okay. That's my diagonal. Cool. I don't really care about the diagonal. I really want to know about the area. So we said the area is equal to 1/2 diameter squared. So my area is going to be equal to 1/2 my diameter squared. So it's 1/2 2 square root of y squared. Well, what's 2 squared? 4. What's square root of y squared? That cancels, so it's just y times 1/2. So it's really 2y. That is my area formula. Once I know my area formula, I can plug it in. You could do this by hand, or by your calculator. It's easier to do it by hand. So that's what I'm going to do down here. Let's find the area of that by hand. What is the integration of 2y? Well, integration, so y squared. I'm going to increase my y by 1, so it's going to be y squared. And then what do I do with that exponent? Divide. So it was 2y, and I'm dividing it by 2, so now it's just y squared. And I want to evaluate that from when to when? 0 to 3. So plug in 3. Because I increased my exponent, I found the integration. I found the antiderivative. It was 2y. I made it y squared, and then I divided by the new exponent. So I divided 2 by 2 to cancel. So it's just y squared, and I'm evaluating from 0 to 3. So I plug in 3. So 3 squared gets me 9, and then I plug in 0. So 9 minus 0 squared gets me 0. So my full answer is 9. Yeah, you're good. You got it. It's 9. Okay. One that's actually, you could do that faster than type in your calculator. Okay, but there it is.